For a confidence level of 99%, find the critical value. So if I have a level of confidence of 99% or 0.99, then I can find a critical value based off of a normal distribution using the formula z sub c equals the absolute value of the inverse norm of 1 minus that level of confidence divided by 2. Now, inverse norm is a function in the TI calculator. If you're using other technology to find that, that's fine, or even tables. Just whatever you use to come up with inverse norm values, that's fine. Now, to understand why this formula works, let me show you a quick application. So, levels of confidence, what we're trying to do is balance a area underneath the curve between two z-scores where those z-scores are the same value. So notice I went and set this to negative 1.74 and positive 1.74, but are as close as we can get to 99%. So here's the thing. If I set that to 2.34, try and get it as best I can. There we go. That's pretty close. I'm at 0.98. So the thing is, I would have to try a lot of different values before I could determine if I was getting that area correct. So instead of trying to come up with this using the area between two values, what we do is we switch this to a complement. So if I take the complement of this green area, complement is the area in these two tails, and it's the sum of both of those. So that complement is 1 minus 0.9807, which is 0.0193, which means because the distribution is symmetric, there's half of that in the lower tail and half of that in the upper tail. So in the lower tail, it's 0.0096. In the upper tail, it's also 0.0096. And then in both, it's double that. And I don't know why it's not updating, but that's okay. So that's the reason the formula looks the way it does. Because we can only use inverse norm with areas to the left of a value. And so we're trying to convert this level of confidence, which is an area between two values, to area to the left. We do that by taking its complement and then dividing by 2, and that gives you the area in the lower tail. All right, so then I'll use the calculator to come up with this. So I would first take 1 minus my level of confidence, which is 0.99, and then divide that by 2. And just make sure to either do that in 2 steps or use some parentheses around the numerator if you're doing it in one fail swoop there. Now, this is what I need to find the inverse norm of. So my critical value is now the absolute value inverse norm of 0.005. So when I put inverse norm, which I would do second distributions, come down to inverse norm, the area that I'm interested in, the area to the left of a value I want, 0.005, and I'm on a standard normal distribution, so I leave the mean and standard deviation to 0 and 1 respectively. If you have your stat wizards turned on, then you're seeing this menu. If you don't have stat wizards turned on, that's okay. What you see is just the function inverse norm show up on screen, and then you would just type in the value 0.005, and you actually don't even have to give the last 2 inputs. You can just give the area to the left, and that's fine. All right, so we come up with negative 2.576. I'm going to make it positive because the absolute value, but I'll write it as 2.58. Traditionally, you might take that to 3 decimals or more, but this is okay for this particular problem. Go into 2 decimal places. And just to verify that that works, if I go back to my app here and calculate area between and set this to 2.58, so lower z-score is negative 2.58, the positive z-score is positive 2.58, that area between is very, very close to 0.99.